All right, last part of the old review works like this. So this is going to be an impulse momentum problem. So remember the rule that I told you. I told you that impulse momentum theorem says impulse equals change in momentum. And we also had the conservation of momentum principle, which said m1 v1 initial plus m2 v2 initial equals m1 v1 final plus m2 v2 final. And so the rule is we use this formula whenever I mention force or time. We use this rule whenever there's no force or time mentioned. And so it's going to work like this. We're going to calculate the time the airbag spends slowing the driver down. And so we're going to use Ft equals mv minus mv naught. So we have 4,000 newtons times the time of slowing down equals 75 times. What's the final speed of the driver? 0 minus 75 times 15. So when we go ahead and simplify and solve, we're going to actually end up getting a time of 0.28 seconds. That's problem number 1. Moving on to the next problem. We have a golf ball that is dropped. And once again, since we do mention time, we're going to probably use the impulse momentum theorem, but we're also going to need a little bit of kinematics to get us through this. We need the speed of the golf ball right before it hits the ground. I don't have the time it falls. This is the time of bouncing. This is the impulse time, not the falling time. To get the falling time, we don't know it. So let's do a formula that doesn't require that. So we'll do v squared equals v naught squared plus 2g y minus y naught. So v squared equals, it starts off at a speed of 0 plus 2 times negative 9.8 times y final is 0 minus a height of 1. So v is going to end up being the square root of 19.6, which works out to be about 4.4 seconds. I'm going to take the negative of that because this is a downward speed. Now, part B, let's get the impulse of the ball, force times time, which is going to be 218 times 0.0018. And when we actually get that impulse, we will get the number 0.39 Newton times seconds. Do not want to see anything else. Finally, we're going to calculate the rebound height of the ball. So the ball then rebounds upwards. So let's figure that out, the rebound height. So Ft equals mv minus mv naught, and that's going to be 0.39 equals 0.046 times v final minus 0.046 times v initial, which is negative 4.4. Sorry, that's meters per second. And so we can actually go ahead, I'll isolate v to start with, and then we'll use that to get the rebound height. So when we solve for v, we're going to end up getting 4.1 meters per second. And then what we would do with that is we get the rebound height using v squared equals v naught squared plus 2g y minus y naught. So here we go. We're going to end up getting the rebound final speed because we're rebounding up to the max height that we're ever going to achieve. That's going to be 0 squared equals 4.1 squared plus 2 times negative 9.8 times y minus 0. So our rebound height ends up being 4.1 squared divided by 19.6. And so we end up getting a rebound height of 0.86 meters. So that's problems 1 and 2.